Hello my dear students, how are you all? Welcome back to our YouTube channel Disha Karnataka. I hope all of you are doing very good. Okay, so today I'm back with your day 30 of ongoing series, which is 16 out of 16 maths, okay, in 100 days. Okay, this is for KCET 2025. So we, as you know, we have started with integration. Okay, we have done 3 sessions. In the previous session, what we did, we talked about particular functions and partial fractions. So we talked about more of what you call particular functions, and I think only 2 questions we did on the partial fractions. Today's session will talk about in detail for partial fractions. So I hope you are able to understand the concept that I'm teaching over here for the integration. Any doubt, any clarification, anything else you want, please make sure that you comment in the in the comment section and let me know what is your requirement. I will try my best to come up and give you a solution for your queries or your requirements. Okay, so moving on, let's see what is coming up. So I hope you are prepared, I hope you are ready. Keep your pen and paper ready, bacha. Okay, we'll solve this session very quickly. We'll complete all the questions very quickly. Okay, so it will not take more than, I think, hour 15 minutes. Okay, so let's complete all the questions. I think I've taken around 9 problems only on partial fractions. So let's see what is partial fractions. So first thing, whenever you have, please see this condition means fx by gx, means there are 2 functions given in the fraction form, fx by gx, okay, and provided what, gx is non-zero. Why, sir? If it is 0, then what will happen, bacha? It will not be defined. So provided gx is non-zero, not equal to 0, then we can call this function to be a rational function. A rational what? Rational function. But in this case, since it is algebraic form, we can call it to be rational algebraic functions. Okay, now think about it. In the rational function, I can have 2 conditions, right? Either this function is more than 1 or less than 1. If you just forget about rational functions, remember rational number. A rational number can be what? More than 1 or less than 1 also. More than 1 means what? The numerator is greater than the denominator. Okay, so same condition. If you have the numerator less than the denominator, you call it as proper rational functions. Understand this. There we call it as rational numbers. Over here, if the numerator fx is less than, okay, so same way, so we are talking with respect to what? Numerator effect. So if the degree of the numerator fx, okay, what is the degree, sir? Highest power of the variable. If let's say it is a quadratic term, I'll give you example. If fx is, let's say, quadratic, if fx is, let's say, quadratic, and this is what, bacha? Cubic, then what is the degree of the quadratic form? 2. For cubic you'll have 3. So of course the fx will be what? The degree of fx will be less than the degree of gx. In that case I can call this function to be proper rational function. Whereas in the other case, whenever you have this degree to be more than the degree of the denominator or the gx, then what will happen? You'll have if you do the long division, you'll have a polynomial, okay, as a quotient, and then you'll get a remainder divided like this. So if you want, if let's say when I divide fx by gx, okay, I get a quotient as, let's say, qx, right or not? Qx, and then I get a remainder as what? I can write this as rx divided by what, bacha? I can write this function as rx plus this polynomial qx plus rx divided by gx as it is. Please check here. So I can write the remainder divided by gx in this form. I can represent this function fx by gx as this quotient. Whatever I get quotient, I'm going to make use of this in one of the question. You'll see. Okay, so I can write this expression, the rational function expression, in this form, the quotient that I'm getting plus the remainder by gx. You'll see how. Okay, I've taken a question on this. We will explain it to you. So let's see. I'll read it for you once. If the degree fx is less than degree gx, okay, it's going to be called as proper rational function. Otherwise, you'll call it as improper rational function. Okay, chaliye. That's all over here, bacha. Now few forms of rational functions that we have, the partial fractions that we have. So please check, please have a look. If you have a look here, so if you see here, there is, I hope this is visible, there is a linear numerator, linear expression as numerator, and you have factors present in it. Like in the denominator there is a quadratic, but there is a factor. So what I'm going to do while writing the partial fractions for this part, for this rational expression, please understand this. So we write our, so let's say what is the first, let me make you understand this. What is the purpose of understanding partial fractions? So what happens is, if you try to solve a question in this form, or integration in this form, it might be complicated. You will not have formulas all the time for each and every statement to be used and to be solved. Okay, then what you do is you break this fraction in this way. Okay, you break this rational function in this way, as with the help of partial fractions. Okay, when you do that, then you can simply integrate this. For example, I can get it as log of x minus a. If it is log, otherwise I can use the exponential function also. So I can use various operations. So various formulas that we have, various rules of integration that we have to perform the integration and get our result. Okay, so to simplify our work, we use the partial fractions. Okay, so let's see. If I have, so we will apply the partial fraction and then the integration. Partial fraction itself is not the integration. Okay, partial fraction is only to simplify the given expression. Then we have to perform the integration as well. Okay, so let's have a look. Px plus q is there. Okay, then what we're gonna do here, since the factors are 2, for each factors we'll write a unknown. Okay, so a upon x minus a and b upon x minus b. Okay, I've taken this a question like this in the previous session where I solved the 2 questions on the partial fraction. This only we used. Okay, this only we used. Okay, chali. What if we have 3 factors in the denominator? So then what we're gonna do? There's a quadratic term in the numerator and cubic term in the denominator. What we're gonna do? We're gonna write here a upon. So we'll have 3 variables that we're gonna take a, b, c as, and we'll have 3 factors written in the same way. So x minus a, x minus b, and x minus c. Okay, same goes for what if I have linear over here, quadratic over here, but in the whole square term. Okay, so I'll write again 2 variables, a by first one x minus a. So why not x minus a over here also? No, please check. If I take a by x minus a, and then I take what? Plus b by x minus a. What is my denominator? What is my LCM of these 2? So it is x minus a only. But what is the LCM? What is the denominator over here? Please check. It's x minus a the whole square. So I must have the same denominator. Everywhere you check, after taking the LCM, no, you'll get the same denominator as the functions, the rational function which is given. See here, x minus a, x minus b. Multiply this, you'll get what? X minus a, x minus b. X minus a, x minus b, x minus c. X minus a, x minus b, x minus c. So for all these possibilities, for all these different functions that is defined here, if you take the LCM on the right hand side, you'll get what? The denominator same as the denominator of the rational functions. This is very, very important. That's why we will not write it as x minus a. Okay, when we are splitting and writing for 2 variables, we'll write x minus a times, then what will be this? The next one, b upon x minus a the whole square. Just this is the mandatory part. You cannot change the denominator. Okay, I hope this is clear. Next here, we have a quadratic term in the numerator. Next we have cubic term here. I'll write what? First a upon x minus a, because it's a whole square here. Please look, whole square here. So x minus a, b upon x minus a the whole square, and c upon x minus b, c upon x minus b. Over here, if I have cubic term over here, so I'll write cubic term, but we cannot factorize this. Please understand this. This expression x square plus bx plus c cannot be factorized. They have given that cannot be factorized. Then what we're gonna do for this term, for x minus a, we'll take it as only variable a. Therefore, quadratic will take a linear one. For this x minus a, we'll take a single variable a. But for this quadratic, we can't factorize it, right? So we'll write bx plus c. We'll take a linear expression as my variable assumption. Bx plus c as my partial fraction. This is also very, very important. I think I've taken a question on this also. Okay, we'll see now. Chali. Moving on. Now moving on to, I hope this is visible for you. Okay, please have a look. Okay, if this is visible, let's move on to the first problem. Okay, first problem, bacha. Achha, one more thing. Not much concepts are there. There's no integration rule over here. Okay, only to understand when to use what. So when to use these forms. Okay, so please have a look. I try to explain you all of it. Just when we have, just understand one thing. Just understand 2 very important points. If I have to summarize it, any variables that we're taking a, b, we can take in any format. Okay, just understand this. The denominator of the partial fraction has to be same as the given rational function. First condition. Second condition, if the given part you cannot factorize, if it is square or if it is quadratic, you will take a linear. You will not get more than quadratic over here, don't worry, but if you do, you have to take quadratic over there. For cubic, you will take quadratic. Okay, but if it is quadratic, you will get a linear as the linear term as the variables. Okay, bx plus c will come in terms of the same variable x only. Okay, so I hope this is clear. Moving on to the first question. Okay, very, very simple question. I think similar one I have solved in the previous session. So how will you, so we have to basically, they have given the form. We don't have to do the partial fraction. They have already given the partial fractions for us. Okay, then we have to just do what, bacha? We have to just solve this expression. How will I solve this? Please have a look. So I will do this. Over here I will write this, okay, as it is. So 3 upon y plus 1, okay, and y plus 4. I hope this is visible. Yes, okay. And then I will write it this as, now I'll take the LCM over here, okay. Please have a look. So y plus 1 and y plus 4, okay, great. Now what is this then? If I take the LCM, I have to multiply a with y plus 4. So I write like this, a times of y plus 4. What about this side, bacha? B times of y plus 1. So right here, plus b times of y plus 1. Now you check here, denominator is same, so we can compare, right? So I can compare what? 3 with what? Please check, a times of y plus 4. Yes, I have to find the value of a plus b. So for that I have to find the value of a and b. So put just y equals to what you put, minus 4. What are you going to get? Please check. I can expand it also. I can expand ay and by. Okay, then I'll get coefficient of y as a plus b. Here nothing, so a plus will be 0 simply. If you want, that is simpler actually. That approach is simpler. But we're going to use this substitution part in the coming questions. So I'll show you. That's why I was using this. Please check. I can do it like this also. Take here. I get what? I get simply as ay 4a by plus b. Acha, I will not be doing all this expansion in every time. I'll show you directly from the bracket. So please check. How will I show you? If I'm writing the coefficient of y, I'll write y first and check the coefficient of y. What's the coefficient of y over here? Please have a look. What's the coefficient of y over here? Simply a, sir. Simply a. What is multiplied to y? Simply a. So in the first term, I have coefficient of y as a. Okay. I'll not do this expansion all the time. Okay. Over here, what is the coefficient of y? Simply b, sir. So a plus b. Do I need to write everything? I don't have to. Please check. What is my coefficient of y over here? So 3 is there. So I can write 3 plus 0y. Because I don't have a y on the LHS side. Do I? How will I compare this? I can write it as 3 plus 0y. It means what? It means what? A plus b is nothing but, compare the coefficient, 0. What is my answer? 0. Simple enough. Simple enough. Very simple. Otherwise, what you can do is substitute the value as y equal to minus 4 and y equals to minus 1, one at a time. If you get, you'll get a value of a and b, add them and get the answer. Any of thing, whichever gives you an answer faster, pick that method and get the result. Moving on. Question number 2. Question number 2. Find integration of, now over here, previous one only they asked for to find the value of a plus b. Over here you have to integrate now. So you have to get this rational expression, rational function in the form of what? Partial fractions, and then do the integration. So let's see how will that pan out. Okay. X plus 1 is there, bacha, right? So how I'm going to write it? I'll write it like this. X plus 1 upon x plus 2, okay, x plus 3 equals to, how will this be? Simply a upon x plus 2, okay, first form, right? First form of the partial fraction. Yes, I'll take the LCM now on the LHS side, on the RHS side. Forgive me. Okay, yes. Now take this, is going to be a times of x plus 3 plus b times of x plus 2. Am I right? Yes, yes. Now, since denominator is same, please check for both LHS and RHS, denominator is same. I can compare just the numerator. So I'll get what? X plus 1 equals to what, bacha? A times of x plus 3 plus b times of x plus 2. Yes, excuse me. Now, in this case, I can do what? Please check. I can put x equals to, I can put x equals to, x equal to what, bacha? X equals to first minus 3. Put a minus 3, what are you going to get? This will be what, bacha? 0. Because minus 3 plus 3 will be 0. So I get what? Minus 3, I have to put on both sides, na? Minus 3 here, plus 1 equals to a times of 0. I'm doing the substitution for only for this time. Next time onwards, I'll take directly. Okay. So linear equations, I think you can understand that. So b times of what? Minus 3 plus 2. How much is that? Simply minus 1. Simply minus 1. What is this, bacha? Tell me. This is minus 2. This is minus b. How, what I get at for b as? B is, sir, simply 2. Please have a look. B is simply 2. I hope this is visible. Yes. Okay. Now I'll take x as minus 2. I'll take what? Please see this. I'll take x as minus 2. over here. What I'm going to get, please check. I'll get here as minus 2 plus 1. So minus 2 plus 1 equals to what, bacha? Equals to what? I'll get over here as a times of minus 2 plus 3. So my plus 1. Okay. And this will be simply 0. Okay. How much I get? Minus 1 equals to a. So what I get for a? A is simply minus 1. Yes or no? Yes, sir. Now substitute this in the integration. How will I split the integration? This will look like this. Have a look. I'll write here this integration I will become what? I will equal to integral of, please have a look, integral of what? First one. I have written like this, no? So what is it going to be? A. So minus 1 dx upon x plus 2. And this will be what, bacha? Plus b. What is b, bacha? 2. So integration of 2 dx upon x plus 3. How come, sir? I have written this function, bacha, I in this format, in the partial fraction. So, okay, please check what is the answer. Minus log of x plus 2 and plus 2 times of log of x plus 3 plus c. This is my final integral value, final integration value. Please check. 1 upon minus 1 I can take common. No, minus 1 I can take common. This is simply what? 1 upon x plus 2. How much is that? Log of x plus 2. This is what? Log of x plus 3. This is my final answer. Please have a look. I hope this is visible. Please have a look. Okay. Yes. Shall I move on? Question number 3. Question number 3. Okay. This I will not solve. This I'll give you hint how to solve it. Do one thing. Write x square as simply y. X square as simply y. If you do that, this is going to become what? Tell me. Integral of y upon y plus 4 and y plus 9. Okay. Okay. dy. Okay. Now what are you going to do over here? Tell me. This will entire thing can be written like this, no? A upon what? If I remove this integration part, please check. If I remove this integration part, I am writing the only partial fraction. A upon y plus 4 plus b upon y plus 9. Okay. Write it like this. Okay. From here you can get the answer for a and b. Okay, get a and b values, and then solve the integration, not partial fraction. We also already got a partial fraction. No, solve the integration. Find the integration. Okay, solve for I. All right, simple. Moving on. Question number 4. I hope you can do this, right? Very simple, no? Just take x square as y and then do this calculation. Same as previous 2 questions. Chali. Now this one. What we going to do, bacha? Tell me. Sir, this looks complicated. This sine and cos also. But if you check here, I can transform. Whenever the thing is, first thing it should come. I think it already comes to you. Whenever you say sine and cos, no, in this kind of questions, there is no direct integration. What do you do? Try to take a substitution. So I'll take a substitution. Please have a look. I'll take my t equals to what? Sine x. Okay. Tell me what is the differentiation now. If you do that, what's the differentiation? Okay. Forget about differentiation right now. I don't have to worry about differentiation right now. First, let me just transform this function. Okay. Let me transform this function first. So this will become what, bacha? Maybe I can do this, right? So let me do this. So it will become what? It will become dt equals to cos x dx. Am I right? So I have differentiated the t. Okay, with respect to x. Dt equals to cos x dx, right? Now what will this become then? Please check. This will become, this whole thing will become integration of 2 dt upon 1 minus t and 1 plus t square. Yes or no? Yes. Okay. Then how will you solve this? Just take the partial fraction. Same way. What are you going to do? Tell me. You're going to do a times of, I'll show you. I'm doing only the partial fraction or the integration. So this will become what, bacha? This will become 2 upon 1 minus t and 1 plus t square is equals to what? Tell me. First I will take it as a upon 1 minus t, and next what I can take? Can I factorize 1 plus t square? No, sir. I'll take what, bacha? bt plus c upon 1 plus t square, sir. Yes or no? Yes, sir. Please have a look. I can multiply this like this. What I'm going to get? So I'll only do for this RHS side. I'll get a times of 1 plus t square, okay, and then add this with bt plus c times of what, bacha? Please have a look. 1 minus t, right? Because I'm taking LCM. No, I'm taking LCM. What is my LCM? 1 minus t and 1 plus t square, okay. If I do that, I'm going to get what? 1 plus t square multiplied with a, so a times of 1 plus t square, and then multiply 1 minus t with this, so 1 minus t. Is it visible? Yes, sir. Okay. Now what we're going to do? Compare the numerators. So I'll write here as 2 equals to, because the denominator is same, right? 2 equals to a 1 plus t square plus, what is this, bacha? bt plus c times of 1 minus t. Have a look. Please have a look. Okay. I will mark this for you. This is my comparison. I'll get the value of a and b and c from here only. Please have a look. You'll see how I'll get. So I'll do what? I'll put t as 1 first. I'll put t as 1 first. If I do t as 1, please check. This will become 1 minus 1, so 0. Please have a look. I'm putting the t value as 1. My t value this as 1. Okay. I can write here only t equals to 1 I'm putting. Okay. If I do that, what I'm gonna get? Please check for this equation. 2 will be as it is 2, because there's no t on the LHS side, so 2 will remain as it is. I'll get what? A times of what, bacha? Tell me. 1 plus 1 square, because I'm putting t as 1, so 1 plus 1 square, and since this is 1 minus 1, so 0. I'll write here as, this whole thing will become 0. Correct, na? Multiplication, so 0. What I get? A times of 1 plus 1 square, so 2. I get my a value as simply 1. How, sir? Please check, please look. I get my, this I get as 2 equals to 2a. So what is this, bacha? A equals to simply 1. A equals simply 1. Okay. Now my a value is known, bacha. Okay. I'll worry about other ones. So please have a look. I'll compare the coefficient of t square. So there's no t square. That's why I'll compare it. Please check. What's the coefficient of t square on the RHS side? So for the, what is the LHS side? So I'm comparing what? Next step. Comparing coefficients of t square. T square. Okay. If I do that, what is the LHS side? Simply 0, sir. What about RHS side? See, a is multiplied with t square. So this is simply a, sir. A plus. What is this going to be? Tell me here. bt is there. If you multiply bt with minus t, what are you going to get? Minus bt square. Please have a look. bt with minus t. Minus bt square. Can you, in any other way you can get this? No, sir. You're going to get what? Minus b. Please check. A with t square means at square. Okay. And this with, please have a look. A with t square will be at square, and over here bt with minus t will be bt square. That's why I've written here minus bt square. Compare the coefficient. What I get? A minus b equals to 0. It means that a equals to b means that also 1. Also 1. Now for c also I'll look, bacha. For c, what I'm going to compare? The coefficient of t. For the coefficient of t. So please check. Or I can compare, constant term also. Please check the constant term. So if I, now what are you going to do? Compare constant term. Constant term. Okay. What's the constant term on the left hand side? Sir, 2. Okay. What is over here? A times of 1 is constant, right? A times of 1, simply a. Okay. What about over here? bt will multiply anything, will have a variable t in it. If you multiply bt with 1 or minus t, will have a variable t in it. If you multiply c with 1, what are you going to get? Simply plus c. So my constant terms are a plus c and 2. What is a and what is a value? 1. So I write it as 2 equals to 1 plus c. What is my c value? Also 1. So I get a and b and c are equal as 1. So this expression will become what? Please have a look. This will become this. If I take this as my integration I, this my integration will become what, bacha? Please have a look. This will become I equals to integral of, please have a look, a upon 1 minus t. What is a upon 1 minus t? A is what? 1. A is bacha? 1. So 1 upon 1 minus t dt will come. Same way, plus, please have a look, plus bt plus c. It means what? Simply b is also 1, c is also 1. So simply integration of t plus 1 upon what, bacha? Tell me. 1 plus t square, 1 plus t square. So write it here, 1 plus t square dt. Both b and c are 1, right? So b into 1, 1 into t will be simply t, and c is simply 1. Now I can break this over here. Integration of 1 minus t dt plus, have a look, I am going to break this, t upon 1 plus t square dt plus 1 upon 1 plus t square dt. Yes, now I can check this answer. This is going to be what, bacha? Simply log of 1 minus t. Yes, 1 minus t is in the denominator, log of 1 minus t. What about this? Multiply 2 up and down and keep this 2 over here outside. If I do that, I can cancel now 2 and 2. So what I'm going to get, 2t is there. Okay sir, we'll see now, we'll see. Okay, we'll see this. Chaliye. All right, dt, this is what, simply, if you remember this formula, tan inverse of t, right, plus c. Yes, no, 1 plus t square is what, tan inverse of t plus c. Have this, check. What is going to get? Log of 1 minus t. Simple enough. Okay, now if I take 1 plus t square as another variable u, or another variable, let's say p, I can write this as, what I'm going to write it as, p, simply p. Okay, what about this? If I take this, please have a look. If I take 1 plus t square as p, what is this, bacha? Tell me. What is this? It's going to be what, bacha? It's going to be, if I differentiate it, it's going to be 2t equals to dp by dt. Yes, dp by dt. What is this? 2t times dt will be, check here, 2t dt will be what? Simply dp. Simply what? dp. Okay, what is this again? Plus tan inverse of t plus c. Okay, so from here you will solve it. From here, solve it. I want you to solve this from here. I've given the last step, just have to integrate this part. You can do it, solve it, and comment your answers. Comment your answers. Okay, comment your answers for question number 4. For question number 4, comment your answer. Okay, just do this integration. All right, chaliye, moving on. Have a look. Just have a look from the beginning. What I did, I resolved into the partial fractions, got a, b, c value as what? 1, 1, 1. Why like this, sir? bt plus c, because this was a non-factorizable what? Non-factorizable quadratic function. So I have to take what? Linear in the numerator. So I took bt plus c. I got this a, b, c value as 1, 1, 1. Okay, please have a look. Then from here, I get my answer as this. Comment below the answer. Okay, moving on, question number 5. Chaliye, aage badhte hain. Okay, how will I solve this, sir? Very simple. This is the second kind, no? When I have whole square, right? How will I take the partial fraction? Please check. Partial fraction, sir, how will I take? Okay, I'll take 2x plus 7, only 2x plus 7. So 2x plus 7, not the integration, only the partial fraction. So x minus 4, the whole square, can be written as, what I'm going to write? Very simple, sir, a upon x minus 4 and plus b upon x minus 4 the whole square, sir. Correct, right? Whole square, no, we have to write. Now please have a look. Take the LCM. So LCM is same, na, x minus 4 the whole square. What is this going to be? A times of x minus 4. Why, sir? Only x minus 4 is there in the denominator. I have to take what? One more time. This will remain as it is. Okay, please see. Now compare the numerators, because LCM is, the denominator is same. So a times of x minus 4 plus b. Simply do one thing, put x as 4. X as 4. What is this value going to be? So you'll get 2 times of 4 will be what, tell me here? 2 times of 4 will be 8. So 8 plus 7 equals to 0 plus b. What is my b value? 15, sir. B is 15, sir. Yes. Now next, what you're going to do? For a, I want to compare only what do you call? A value. Compare the coefficient of x. What is it going to be? Tell me. So for a, what I'm doing? Compare coefficient of the variable x. What is that over here? So 2x, if you see, is written as ax. Anything else can come for x? No, sir. Only ax minus 4 is there. No. So I'll get only one term for the x, ax. What is it going to give me? A equals to 2. A equal to 2. So if I take this as my integration I can write this again. I as, please have a look. I as I equals to integral of what, bacha, tell me? To 2 upon x minus 4 dx plus what is this? 15 upon x minus 4 the whole square dx. Am I right? Please have a look. A upon x minus 4. So 2 upon x minus 4 because a is 2, and b is 15. So 15 upon x minus 4 the whole square again in the integration for this fraction. Okay. Now do this integration. What is the answer? What is it going to be? Check here. 2 times of log x minus 4. Yes, bacha. And what about this? I'll take 15 out. Okay. I'll integrate this part. I'll get it as x minus 4 minus 2 plus 1 divided by minus 2 plus 1 plus c. Okay, what is the answer? Please tell me. My I value is 2 log of x minus 4. Yes, 2 log of x minus 4. What is this going to be? 15. Okay, how much is that? Achha, minus 2 plus 1. How much is this? Negative, right? So negative means I can take the sign over here only directly. So this will become minus. Please have a look. Minus 2 plus 1. Negative. So I can take here minus. Divide by what, bacha? X minus 4 power. Minus 2 plus 1. Minus 1. So simply write it as x square. No, sorry. Yeah, x minus 4. Not x square. X minus 4 plus c. Any option like this? Please have a look. Please have a look. 2 log x minus 4. Okay. 2 log x minus 4 minus 15 x minus 4 plus c. Option number C. Okay. Option number C, sir. Option number C. I hope this is visible. Partial fraction over there. Okay. Moving on to integration. We got the answer to be 2 log x minus 4 minus 15 upon x minus 4. Okay. Alright. This is simple. Very, very simple. I can move on to the next problem. Question number 6. Chaliye. Okay. I have a cubic term. Again, one of the kind I have taken again. So see what is this kind of the problem. And I can resolve the partial fraction. I'll get, I think, lot of variables here. So let me just, I'll get more variables here. Okay, but I'll try to get it over here only. See, I'll require more space, bacha. X square upon x minus 1 the whole cube x plus 1. Why I'm saying more variables? Please have a look. I have how many I have factors? I have 4, sir. X minus 1 is coming 3 times, and then one time is x plus 4. So I can write this as, please have a look. First a upon x minus 1. Next what? Plus b upon x minus 1 the whole square plus c upon x minus 1 the whole cube. This is just for x minus 1 cube, right? I have to write for three values a, b, c like that. What about last one? Plus d upon the last one, x plus 1. Now if you take LCM, what are you going to get? Please check. You're going to get this as a times of, please have a look, a times of, I think this will not be fitting here. I'll take the entire space. It does not fit here. So I'll take it like this. Please look. Please have a look. Okay. So if you look at over here, I'm going to get what, bacha? Tell me. So I'll get this right as it is, x square upon x minus 1 the whole cube and x plus 1. I've written the LHS as it is. Okay. As it is. Equals to, have a look. A times of what? Tell me. I have x minus 1 only. So I'll get what? X minus 1 square times of x plus 1. Because what is my LCM? Please have a look. LCM is x minus 1 the whole cube and x plus 1. So over here if you compare, x minus 1 square is missing and x plus 1 is missing. So you multiply over here to make the equivalent fraction. No confusion there, right? Not allowed to have this confusion. What about b? I have 2 square is present there. So I am missing only one time. So I write here b as x minus 1 and then x plus 1 is missing. So I write it as x plus 1. Okay. B is also done. X plus 1. Okay. X plus 1. Now with c. With c I have already x cube. So I'll need only what? X plus 1. What about d, bacha? What about d? For d I'll get what? Entire x minus 1 the whole cube. Because x plus 1 is already there. Okay. Already there. This is visible. Yes. Now have a look. Please have a look. So please see here, if I compare, so I'll try to put what first values wherever it's possible. Okay, so I'll put here. It'll take time to solve it because you'll have to find what, how many variables. Check here, A, B, C, D. So you have to keep a little bit patient with me. Okay, so let's see one thing. We'll put x equals to first 1. Okay, I think I have enough space. So let me just rewrite this whole thing again. Can I write it over here? So just I'm writing only the numerator part on the this side. Please check here. I have denominator is same. Denominator is same. I'm going to take what, x square and this numerator. So please have a look. I'll write this as x square equals to, okay, not difficult but you know, calculative, a times of x minus 1 square and x plus 1, a times of x minus 1 the square and x plus 1. Okay, what about b, x minus 1 x plus 1, b is x minus 1 x plus 1. What about c, x plus 1, only c, x plus 1. Okay, so plus c x plus 1 and plus d x minus 1 the whole cube. Okay, now please have a look. Put x equals to 1. Put x equals to 1. Tell me here, 1 means what? I'll get what? 1 square on the LHS side. Over here, 1 minus 1 will be what, bacha? 0. So a times of 0. Please have a look. 1 minus 1, so 0. Here also b, 1 minus 1, again 0. What about this? No sir. Plus c times of, I'll get 2 sir. What here? Again 1 minus 1 0, so plus d times of 0. Yes or no? Yes. Please have a look. So I get what? 1 equals to 2c. So what is my c equals to? C equals to 1 by 2. One of the answer is this. One of the answer is this. Okay. Now I'm going to put x equals to minus 1. X equals to minus 1. Please check. I get what? Minus 1 the square equals to, again here 0 because x plus 1 is there. So a times of 0. Because anything, if it, one of the bracket is 0 means whole thing will be 0, right? Because product is there. So 0. Over here also 0. So b times of 0. Am I right, sir? Over here c times of 0. Because I'm taking minus 1. So this will be 0. What about the last one? Plus d times of, sorry. Let me rewrite this part. Looks confusing. Okay. Yes. Plus d times of minus 1 minus 1. Simply what? Minus 2 the cube. How much is that, bacha? 1 equals to minus 8d. So how much is d? How much is d? D is simply minus 1 by 8. Minus 1 by 8. Okay. So d is also done. Now put x equals to 0. I'll put x equal to 0. Please have a look. I'm putting x equal to 0. I'll get what? 0 on the left hand side because 0 square. Okay. Now if I do that, what am I going to get? Please check. A times of 0 minus 1 is what? Simply 1. And 0 plus 1 is also what? Simply 1. Okay. 0 minus 1 the square is minus 1 square, so simply 1. Okay. What about this? Again I get 0 minus 1. So what will this be? Please check. B times of minus 1. Okay. Over here what? 0 plus 1. So simply 1. Okay. What about here? Plus c. I get what? C times of 0 plus 1. So simply c. And over here I get what? D times of plus d times of 0 minus 1 the cube. Please check this equation that I'm getting. I'm getting 0 equals to a minus b plus c minus d. Yes or no? C with positive of this 0 plus 1 will be positive only, no? This is c, bacha. This is c. Okay, let me rewrite this part. Looks confusing. So c 0 plus 1 is what? C only. And this is minus 1 cube is going to be what? Minus 1 only, so minus d. So I have c and d value. So what I'm going to get a and b as? I'll get a and b, a minus b as d minus c. If I bring this on the 0 side, d minus c. What is d minus c? Minus 1 by 8 and c is what? Minus 1 by 2. Take this LCM. How much is this? So 8 is LCM minus what is this? 1. And how much is this? 4. So minus 4. How much is the answer? Minus 5 by 8. Yes or no? Please have a look. So minus 1 by 8. Okay, d will come on this side, will become plus. So d is minus 1 by 8 and c is going to be minus 1 by 2. LCM is 4. 2 times 4, yes, minus 4. So I get a minus b as this my answer. So I have to find what? To find a and b, I need what value? I need a plus b value. So let's put x equals to, see, if I put 0, I get negative, negative. If I put 2, I might get positive because 2 minus 1 will be positive only. So let's try here. X equals to 2 I am putting. X equals to 2. okay, x equals to 2 I'm putting. If I do that, what I get on the LHS side? 2 square, so 4. What about this? 2 times a times of 2 minus 1. How much is that? Please have a look. A times of 2 minus 1. So simply 1, and this what? 2 plus 1 is simply 3. Please have a look. A times of 2 minus 1 is 1, and this is going to be 2 plus 1, so 3. Okay. What about B? What about B? Please check. B times of 2 minus 1, so simply 1, and 2 plus 1, again 3. Please check. 2 minus 1 is 1, and 2 plus 1 is 3. So I get what? 1 times of 3 again. 1 times of 3 again. Okay. Let's check with C. Let's check with C. I get 2 plus 1, so 3C I'll get, simply 3C. 3C. And plus D. 3 minus 1 will be what, bacha? Tell me. 2. 2 cube is going to be what? 8. So 8. Okay. I get what? Okay. I've taken, sorry, forgive me. Please forgive me. I took it as 3. I don't know why. Because I've been saying 3 all the time. Okay. I have to take x equals to 2, right? Please have a look. I'm taking x equals to 2. So if I take there d as x as 2, 2 minus 1 will be simply 1. So plus d will come. Only plus d will come. Okay. So have a look. I have 3a plus 3b plus 3c plus d. Okay. Equals to 4. What do I have? I have 3a plus 3b plus 3c plus d equals to 4. So I get what? 3 times of a plus b. What is my 3c? 3 times of 1 by 2, so 3 by 2. And d is what? Minus 1 by 8 equals to 4. Bring everything over this side. I get 3 times of a plus b equals to 4 minus 3 by 2 plus 1 by 8. Take the LCM, bacha. LCM is 8. So 24. Okay. Not 24. Not 24 actually. Is it 24? No. 32. So 32 minus 2 times 4. So minus 12 and plus 1. How much is that? Tell me. You get it as 20 plus 1. So 21 by 8 equals to 3 of a plus b. Cancel this with 7. I get a plus b equal to 7 by 8. My a minus b was what? A minus b was minus 5 by 8, I guess. Please have a look. A minus b was minus 5 by 8 over here. Minus 5 by 8. Add them. Add them. What are you going to get? Please check. I get 2a equals to 2 by 8. So I can cancel 2 and 2. So I get my a value from here only as 1 by 8. So my a value is 1 by 8. Okay, a value is 1 by 8. Alright. So if I know a, can I find b from here? If this is 1 by 8, this will be what? This is 6 by 8. Because a plus b is 7 by 8. A is 1 by 8. So b will be what, bacha? Tell me. B will be 7 by 8 minus 1 by 8. How much is that? 6 by 8. How much is that? 3 by 4. So b is what? 3 by 4. Okay. Now I'm going to solve the question that they're asking. So if you remember the expression, it was given by integration I was given by, have a look over here, x square. This if I take this as my I, okay, I'm writing this as a upon x minus 1. A upon x minus 1. This will become what? What is a? 1 by 8. So 1 by 8 upon integral of 1 upon x minus 1 dx. Please have a look. I'm writing a as 1 by 8 and this is nothing but 1, right? So I write it as 1 upon x minus 1 integration dx. Next is what? B upon x minus 1 the whole square. Okay. What is my b value? My b value is 3 by 4, right? So plus 3 by 4 integration of 1 upon x minus 1 the whole square dx. Yes or no? Please check. Please have a look. B upon x minus 1 the whole square. Next part. Next what? Next I have to write for c. What is my c? 1 by 2. C is what? 1 by 2. So again I'll take 1 by 2 common, integration of what will come? 1 upon x minus 1 the whole cube dx. Have a look. C upon x minus 1 the whole cube dx. What about d? D is minus 1 by 8. D is minus 1 by 8. I'll get it as minus 1 by 8. So I'll get it here as minus 1 by 8 integration of 1 upon x plus 1 dx. Have a look. Yes or no? Yes sir. Okay, chaliye. Let's solve this. Let's get this answer. I'll get it as 1 by 8 log of x minus 1. What I'm going to get over here? Please look over here. 3 by 4. This will be simply what? X minus 1 minus 2 plus 1 divided by minus 2 plus 1. Okay, what about this? I'll get what? Plus 1 by 2. What will this be? x minus 1 minus 3 plus 1 upon minus 3 plus 1. Okay, integration of the polynomial part. Okay, what about this? I get it as minus 1 by 8 log of what, bacha? Log of what? Tell me. X plus 1. Yes. Okay. All right. Yes. Chali. So any option like this? Okay, no problem. So I am getting an option like this, but I have to simplify it a little bit more. Any option like this? Yes. See, minus 3 by 4 and 1 by 4 is already here. Please have a look. Minus 3 by 4 and 1 by 4 is already here. So let me simplify this. My integration I will be written from here. Check here. I have 1 by 8 and 1 by 8 common. So take here 1 by 8 common. What I get? Tell me. I get log of x minus 1 minus log of x plus 1 or not. Please look. I am taking this part and this part common, bacha. 1 by 8 I have taken common. So log of x minus 1 minus log of x plus 1. Okay. Now what about this? This is minus 2 plus 1, right? Minus 2 plus 1. This is minus 2 plus 1. I get what? Minus 1. So it will become what? Minus 3 by 4. Minus 3 by 4. What will this be? In the denominator. So x minus 1. Okay. X minus 1. What about this one? I get it over here as minus 3 plus 1. So what is it going to be? Minus 2. So I get what? Minus 1 by 4. And what will this be? Please check. In the denominator as x minus 1 the square plus c. This is my answer. Please have a look. I'll show you how, but this is my answer. Okay. Shortage of steps has made me do like this. So I hope you understand this. 1 by 8 log of x minus 1. So log a minus log b is what? Simply log of x minus 1 upon x plus 1 or not. So I'll look for the first term as 1 by 8 log of x minus 1 upon log of x plus 1. 1 by 8 log of x minus 1 upon log of x plus 1. So either b or d. 1 by 8 log of x minus 1 upon x plus 1. Why, sir? Log a minus log b. Log a minus log b is what? Log of a plus b. So x minus 1 upon x minus 1 upon x plus 1. So option B or D. Other option, please check. Minus 3 by 4 x minus 1 in the denominator. Minus 3 by 4 x minus 1 in the denominator. Over here I have plus. So wrong, sir. Okay. This is also true. 1 by 4. So option number B is correct. Option number D is correct, I mean. Forgive me. Option D. Because this here has to be negative. Plus and plus it has given. In the question that we go solved, minus 3 by 4 and minus 1 by 4 was there. This is my answer. Okay. So I'll have you, I hope this is visible. Please have a look. First thing was, we had to identify and break this into 4 variables. We have break it into 4 variables A, B, C, D. We got this by comparing the answer as, a coefficient like this. C came as 1 by 2, D came as 1 by 8, minus 1 by 8. A minus B came as minus 5 by 8, and A plus B came as, what is it? 7 by 8. From there we got A as 1 by 8 and B as 3 by 4. Okay. And then what we did, we used this in integration and got my answer as 1 by 8 log of x minus 1 upon x plus 1 minus 3 by 4 upon x minus 1 and minus 1 by 4 times of x minus 1 the whole square plus c. Simple enough. Okay. Not simple, sir. Understand, but sometimes the question will be difficult. Okay. You cannot expect a question to be of the same kind. One more thing, if you look at this, steps are required. Okay. But look, the thing is, I'm not saying that this question will come in examination. I'm saying that this is to build your concepts. We are studying for examination, I understand that, but we are trying to build your strength to withstand this kind of question. If you are having the strength going in the KCET examination, you'll certainly score better marks in the simpler questions. So this is what making your brain think and work. So what I did in the given time, okay, I was able to solve all the steps without missing anything, without making any mistake. If you are able to do the same thing, it means you are trained to, you are trained, by practice, you have become efficient in solving a complex question. Okay, not complex actually, simple only. The procedure is very simple, but it is calculative. Okay, so I hope everything was visible from here. Please have a look once again if you need to, and let's move on to question number 7. Question number 7. Okay, chaliye. Value of dx upon square root of x and then cube root of x. Okay. All right. See here, something like x power 6 and 6 is coming like this. Okay, in the options. So let me just take some substitution over here. I'll take x equals to t power 6. Differentiated, bacha. I get dx equals to what? Tell me. 6 t power 5 dt. Right? Right? So this integration will become what? Tell me. It will become I will be equal to 6t power 5 upon, okay, dt upon square root of t power 6 will be what, bachcha? Tell me. Square root of x means square root of t power 6 will be simply t power 3. Yes or no? Please check. I have taken x as t power 6. If you take square root of that, you will get what? T power 3. If you take cube root, what are you going to get? Simply t square, sir. Yes or no? Now please have a look over here on this side. So if I take this integration over here, I get what? I can take t square common in the numerator. So okay, let's just write it like this only. Numerator I will not change. I can take t square common over here. I get what? T plus 1. Yes, t plus 1. Okay, cancel this. I get 3 here. What is my left out part? 6t cube dt upon t plus 1. T plus 1. Okay, 6 I can keep it outside, bachcha. 6 I can keep outside, bachcha. Okay. Yeah, I said no. Sometime what happens, we will take this as, you know, a differential, what do you call, we write this, whenever the degree is more for the numerator, we write this as a quotient qx plus a remainder rx upon the same thing, the divisor gx. Okay, we'll express this thing. Please look here. What's the degree in the numerator? T cube. Over here, what is it? Only linear. So I will divide this t cube by t plus 1. Long division method. You'll check. So let's look at this. Very fun. I can write this as t cube. Okay, forgive me. I'll write t plus 1 over here, right? T plus 1 t cube, and this is my divisor. Okay, so I'll take what? I have to take out the first thing. What I'm going to get? Multiply with t square, sir. Multiply with t square, sir. What I get here? Please check. I get t cube plus t square. Take a minus sign. Sign change will be there. This will go out. I'll get what? Minus t square, sir. I have to multiply now what with? T with minus t. When I do that, what I get? Please have a look. Please have a look. I get it as minus t square minus t, sir. Minus t. Now what I'm going to do? Again subtraction. So sign change goes out. What I get? Simply t, sir. What I'm going to do now? Multiply it with plus 1, sir. I get what? T. And what I'm going to get here? Plus 1. Sign change goes out. What is this answer? Remainder is minus 1. Remainder is minus 1. So I can express this function. What I had this as t cube upon t plus 1 as what, bachcha? Tell me. I can write this as t square minus t plus 1. This is my quotient, and minus 1 upon t plus 1. Yes or no? Please have a look. Please have a look. Yes? Okay. Okay. Chaliye. Let's solve this question now. So I have to do what? My integration I have to do. Okay. So I'll write this integration I equals to what? Integral of this whole thing. So I'll get this as what is my t cube? Can I do this right now and then deal with it later? Please let me try. Let me try over here. I'll deal with t right now. If I integrate this, I'll get what? Integration of t square. 6 was there, right? Or 6 was there outside. T square dt minus integration of what? Simply t dt. Okay. Integration of what? Plus dt. Okay. And minus dt upon t plus 1. Can I do it like this? Let me just check quickly. Can we do it like this? Okay. I don't think that we should, but maybe. Okay, it will not make that difference. So I get this as 6 upon, what does this tell me? T cube by 3. Yes. What about this? I get it as t square by 2. Yes, I get it as simply t. I get it as log of t plus 1. Okay, plus c is there, plus c is there. Now multiply 6 on the everything. I get I equals to what? Please have a look. I get 2t cube minus 3t square plus 6t minus log of t plus 1 plus c. Now what is my t value? T value is what, bachcha? Tell me. T is going to be, t is what? Tell me over here. If x is t power 6, what is t? T is nothing but 6th root of x. Yes or no? Yes or no? Yes. Okay. Now have a look. So I'll write this again over here. I'll write the same statement of first this. I equals to 2t cube minus 3t square minus 6t plus log of 1 upon log of 1 minus t, log of t minus 1, I think, or t plus 1, check here, t plus 1 minus log t plus 1, okay. This is plus 6t, okay, plus 6t, alright. 2t cube minus 3t square plus 6t plus minus, this is minus plus c. I replace the values now for x. I get it as 2 times of, what is my this thing, tell me, t is going to be what, bacha? 6th root of x the power 3, over here 3 times of 6th root of x to the power 2, over here plus 6 times of 6th root of x, right, 6 times of 6th root of x, okay, and last one minus log 6th root of x plus 1 plus c. Am I right? Yes. Now have a look over here. My final answer will become 2 times of, I have 1 by 6 as the root, right, because root means what, 1 by 6 power, so it will become what, 1 by 2, so I will get what, root x, okay. What about this, I will get it as square, right, so I will get it as what, simply 3, and I will get it as cube root of x. If you are worried, check here, 6 root of x the whole square will become what, x to the power 1 by 6 the whole square, will become what, x to the power 2 by 6, will become what, x to the power 1 by 3, will become what, cube root of x, cube root of x. Same thing I have written here, cube root of x. If you're not sure, I have written over here just to see, okay, just to understand, for explanation, okay, that's for explanation, okay. Over here this I cannot change, 6 times of cube root of x, and this will be same as it is, log of cube root of x plus 1 plus c, okay. Let's check the answer, which option is correct, okay. 2 root x minus 3 cube root x, okay, option number C, I think, right. I did not multiply 6 over here, sorry, this is 6 over here, bacha, because I am doing expansion, right, so 6 will be there everywhere. So 2 root x minus 3 cube root of x, okay, plus 6 root of this, option number C is right, option number C is right, okay. This is just to make you understand that how this is coming as cube root of x, so don't need this answer, okay. This is not part of your answer. I hope you understand this, okay, just to see how it is coming as cube root of x, okay. This is my final answer, I equals to this. Visible? Yes, visible, sir. All right, moving on, chaliye. Question number 8, 1 minus cos x times of 1 plus cos x, okay, 1 plus cos x. Can I take something right now as this, let me do this as cos x equals to, let's take cos x equals to t, okay, because right now I am not able to see this pattern, but if I do it like this, I get what, only for fraction, not integration, only for fraction. I am doing it as 1 minus t upon t times of 1 plus t, or not, what I get, 1 minus t upon t plus t square, t plus t square, yes, okay, t plus t square. Now please have a look, I can write this as same thing, I don't have to write the multiplication also, don't write the multiplication over here, because I have to find what, partial fractions, so I have to multiply now. So I can write this as, if you have a look, 1 upon t minus 2 upon 1 plus t. Please have a look. If you take LCM over here, what are you going to get? T times of 1 plus t, okay, I am just showing you the LCM part, it will become what, 1 plus t, okay, and then I do what, 2 times of minus t, so minus 2t, what am I going to get, 1 plus t minus 2t, 1 minus t. So this is for this part. So this I can see directly over here, so that's why I'm doing like this. If you're not sure about this, do the partial fraction. Write the partial fraction like this: a upon t and what are you gonna get? Sorry, plus b upon 1 plus t. Take it like this, and you'll get the answer as a as 1 and b as 2. okay, b as 2, nothing different, okay. I'm just doing it directly, please have a look. So if I do this now, I can integrate, right? I can integrate in this form now, back to this form. What is my t? Cos. So I write it as integration I equals to integration of 1 by cos x dx, okay, and minus 2 outside, 1 upon 1 plus cos x dx. Nothing different, okay. I have not taken this dt form, only just to understand the partial fraction. I took it as t and now I have substituted back cos as t, okay, cos x as t. Now have a look. Please have a look. So I'll get I equals to what I'll get, bacha? Integral of cos x will become what? Simply sec x. Simply what? Sec x dx. Am I right? And this will become what? Minus 2 times of 1 plus cos x means what? It means 2 cos square x by 2. Yes? 1 plus cos x can be written as 2 cos square x by 2. Okay, because cos 2 theta, this formula I am saying. Cos 2 theta is equal to what? 2 cos square theta minus 1. So bring this 1 over here, it will become what? 1 plus cos 2 theta. You will get what? Same form, 1 plus cos x. 1 plus cos x. This is cos x, bacha. Have a look. Have a look. This is a cos x. So I'll get the angle of a square as x by 2. Cos square x by 2. So what I get this as? Simply, what is the integration of sec x? Log of sec x plus tan x. Log of sec x plus tan x. Okay. What about this? I get it as this 2 and 2 will be cancelled, right? So I get it as integral of what? Tell me. Integral of sec square x by 2 dx. Am I right? Sec square x by 2 dx. This integration is done. Okay. What is this answer? Tell me. Can you tell me this answer directly over here only? I'll get this as minus tan x by 2 upon what? 1 by 2, right? No. Please check. Sec square integration is tan x by 2. I have to divide by a, so 1 by 2. I get it as 2 minus, so I get this 1 by 2 over here will become minus 2. So check any option like this. Please check an option like this. Log of sec x plus tan x. So 2 options are there. Okay. I have a minus sign here, minus 2 should come. So only this option is correct. Okay. So option number A. Done. Extremely simple question. Okay. Moving on. Question number 9. Okay. Question number 9. Okay. And I think this is the last one of the day. Okay. Let's solve this. Let us solve this question, sir, quickly. Okay. But it's a very good question. It's a very good question. Okay. You will see now. So what's the question given? Dx upon 1 minus cos x minus sin x integral. Okay. Options are given A, B, C, D. We'll see how this works out. So I'll take this. If I take this as my integrand I, okay. So I can write this as like bacha. Please have a look. I equals to, please have a look, dx as it is, 1 as it is. I can write cos x as, if you remember this formula, 1 minus tan square x by 2 upon 1 plus tan square x by 2, sir. Yes, this is my cos 2 theta formula. This is the formula of cos 2 theta. 1 minus tan square theta upon 1 plus tan square theta. Okay. What about sin 2 theta? Minus, okay, 2 tan x by 2 upon 1 plus tan square x by 2. Yes or no? Please have a look. Yes or no? Okay. Now if you do this, I get to I equals to integral of, take LCM over 1 plus tan square x by 2. What am I going to get? Please check. This is going to be dx over here without any change. I'll get this as 1 plus tan x by 2. 1 plus my denominator for this. Okay. LCM 1 plus tan s square x by 2. Tan square x by 2. Okay. What is this 1 here? I have to multiply the same thing now. 1 plus tan square x by 2. Check this. This is same thing, right? I have to open the bracket. LCM is this denominator is same. So I'll open the bracket. You'll get minus 1 here. You'll get plus tan square x by 2. Same thing over here. Simply minus, just open the bracket, minus 2 tan x by 2. Okay, please have a look. I can cancel 1 and 1. What I'm left with? 2 tan square x by 2 minus 2 tan x by 2. Yes. Alright. So I can write this, if you allow me, I can write it over here only as my integrand I equals to, please have a look, dx upon this upon this. So this will go where? In the numerator. This whole thing will move to numerator. It will go what? 1 plus tan square okay, I equals to integral of 1 plus tan square x by 2 times dx will come in the numerator, divided by what? 2 tan square x by 2, 2 tan square x by 2 minus 2 tan x by 2. Have a look, please have a look. 2 tan square plus tan square, 2 tan square x by 2, and this is what? Minus 2 tan x by 2. Okay, now have a look on this side. So get my integration as, I'll get my integration over here as, okay, I hope this was understood, right? This denominator over here will go to numerator only, no? So I multiply this with numerator, okay? This is just 2, not visible. Let me just rewrite this. Tan square x by 2, same thing, nothing is different, okay? Have a look. So this is my integration I will change into integral of 1 plus, I'm writing the same step again, x by 2, dx is there obviously, and what is this going to be? 2 tan square x by 2 plus, oh no, this is minus, sir, minus 2 tan x by 2 bacha. Yes, yes, okay. Now do one thing, write this as integration of what? Okay, I'll take 1 plus tan square is what? 1 plus tan square, identity, sec square theta. So sec square x by 2, okay, I'll take this 2 common, write it as tan square x by 2 minus tan x by 2 dx. Now do one thing, over here take tan x by 2 equals to t, okay, substitution. What's the differentiation of this? Sec square x by 2 multiplied with 1 by 2, because I have to do the chain rule. Sec square x by 2 for the tan, and 1 for x by 2 I'll have 1 by 2. This is going to be what? Dt by dx. Bring this dx over here, what I gonna get? Please check. 1 by 2 sec square x by 2, okay, dx equals to dt, dx equals to dt. Just the last problem, okay. I know the chapter is a little bit tricky, difficult. We have to work hard to get better, bacha. We have to work hard to get better. Now please have a look. This 2 is present here, right? I can move it to numerator. It will look like this: 1 by 2 sec square x by 2 dx. I'm writing all the steps for your benefit, so that you are not able to, you don't have any confusion, so how this step is coming, okay. So when you're going through the PDFs, no, you should not have any confusion. This will become what? 2 times of, not 2 is gone now, 2 is gone, bacha, right? Because I've taken in the numerator, 2 is gone, okay. Simply what? Tan square of x by 2 minus tan x by 2, okay. This will become what? Tell me. Dt, sir. This will become dt, sir. So I'll write my integration I as dt upon t square minus t. Yes or no? Please have a look. Tan x by 2 is t, so tan square will become what? T square minus t. Now next step. Integral of I equals to integral of what? Dt upon t square minus t. Please expand this. What am I going to get? Dt upon t times of t minus 1. Okay, I can write this as, I can do, you have to do again what? Write this as a upon t plus b upon t minus 1. But I can see from here only, it should be 1 upon t minus 1 minus t upon, sorry, not t, 1 upon minus 1 upon t. Please have a look. Please have a look. If I do this, take the LCM, I get what? T minus 1 in the bracket upon t times of t minus 1, right? I get what? T minus t plus 1 upon t times of t minus 1 goes out, it becomes what? Simply 1 upon t times of t minus 1. Same thing over here. Please have a look. Same thing is over here also. So I can write like this. If you are confused over here, do the partial fraction part. Do the partial fraction part and solve this. Chaliye. Okay, let's solve this. What I'm going to get? Simple. This is the very, very simple. Integral of 1 upon t minus 1 minus integral of 1 upon t. Both sides we have dt dt. So my I will become what, bacha? Tell me. Log of t minus 1, okay, minus log t minus log t, and plus c is there, the constant of the integration. Okay, so log a minus log b, I can write it as, tell me, log of t minus 1 upon t plus c. Yes or no? Please check. Log a minus log b. Log a minus log b is what? Log a plus b. Okay, so divide this. Log of t minus 1 by t plus c. I have taken this division. T minus 1 upon t is there, so will become what? T upon t minus 1 upon t. It will become not t, it will become simply as 1, right? It will become simply as 1, bacha. Please have a look. T upon t will be 1 and minus 1 upon t will be simply minus 1 upon t. What's the t value? Please tell me. Please understand this. T value is going to be what? 1 upon tan of x by 2 plus c. How much is this? Tell me. Log of 1 minus cot of x by 2 plus c. This is my final answer. Please have a look. Please have a look. Log of 1 minus cot of x by 2. One minus cot x by 2. Please look from the first step. Okay, this is visible. First we transform this in this formula using, what is the formula that we used for cos to theta? Okay, we use for, if you want I can write it like this. Cos of 2 theta equals to what? 1 minus tan square theta upon 1 plus tan square theta. And what is sin 2 theta in terms of tan? 2 tan theta upon 1 plus tan square theta. Yes or no? Please have a look. Yes or no? Okay, from there we do the simplification in the denominator. Okay, and from there what we did, bacha? What we did? Tell me. We got this as yes. This will go to numerator. This is nothing but sec square theta. Again took 2 up and took the substitution tan. This is my substitution. Substitute this as t. Okay, what is my answer? My answer is going to be, I hope this is visible, log of 1 minus cot t cot of x by 2 plus c. Okay, so with this, okay, we complete our partial fraction part. Okay, so this is it, bacha. I hope you enjoy the session, because I did. It was very extensive, it was very engaging. Every time we were solving everything, but we were able to solve every single question. Okay, so I hope this was very, very fun. I know you are asking more questions on calculus. I am trying to come up with better and better questions to make you make your mind go a little bit puzzled. If you're not puzzled, means you're not in the comfort zone. Your mind has to be uncomfortable. If you're finding it difficult, means good, means you're thinking about it. If everything is easy, means if you're not understanding, means it's just waste of time. Easy means yes, very good. Everything is easy for you, even the KCET problems, very good. You'll crack KCET with the outstanding rank. Okay, but if it is not, you're thinking too much, not putting your brain only, then there's no effort. Difficult means you are thinking about the question and you are getting it wrong. So just over there, one more step is required. Put some effort, watch the sessions, solve the check the solutions, how I have solved it, see what I'm trying to So every solution is the thing is there's a difference of just giving solution and explaining everything. Okay, so when I'm giving a solution, there's a trend, how I'm thinking. Try to think like me. Okay, try to think that what I'm thinking, what is coming next. If you are able to think the next step, then you are through with the solution. Okay, so think, what is my approach, what is the flow of the question, so how we are going in the question. It should not be random. Okay, the flow should be in a certain way. If you think like this, even if you don't write all the steps, if the flow in the brain is right, you'll get the correct answer every single time. So try to develop that, especially in the integration, because questions are lengthier, sir, and there are a lot of the first thing is lengthier chapter, lot of formulas, lot of concepts. Okay, one more thing, as we completed, whatever topics we have done, write all the formulas at one place. Keep a formula sheet for integration and entire calculus actually, because if you don't keep it, you'll be confused. Even if you remember, you'll be confused, because there are similar formulas here and there. So even if you remember something, but since you're not sure about it, you'll make a mistake and lose marks. So you cannot have this liberty to lose marks because of the formula. So keep a formula sheet. From here only you maintain the formula sheet for calculus. Okay, do this and follow the flow of the question. Try to, whenever I'm solving a question, don't look for solution. Don't try to overreach the solution. Try to think how I'm thinking about the question. Whenever I'm explaining you, I'm trying to explain you, okay, sir, okay, this is what I'm thinking right now. This is what I'm doing right now. I'm trying to think as a student. How will a student think of a question? So try to break your problems in this way. I will certainly hope that you'll get a more success while solving the problems in integration. So with this, I'll try to end the session. Keep working hard. Be positive. Whenever you have a difficult time, otherwise you will be positive, right? Around your friends, positive, sir. But whenever you are having difficult time, that's your challenge. When you have to, that's the challenge of your character. Then at that point, can you stay positive or not? If you can, very good. That's what we are aiming for. Keep working hard. Be have a smile on your face. I'll see you in the next session. For now, take care. Bye bye. See you, bacha.